Welcome back, grade 12s. We're going to look at page 17 to 19 today in 4.9, where we combine our differentiation rules that we have learned. The power rule, which we've sometimes called elementary rule, and the product rule, the quotient rule, and the chain rule. Beside each of these questions, you'll notice there's the question, which rules apply here? And we're going to talk about that as we go. So h of x is given here, and you can see that it's got two parts are being multiplied together. So most likely here we're going to use the product rule. We see this part is f, right? And this part is g, just like we did when we learned the product rule. Okay, let's look at f. The part f is 2x minus 1 all to the power of 3. The derivative of f, though, we need to use the chain rule. You can see that this 2x minus 3 is to the power of 3. So the chain rule says that the derivative will be the exponent multiplied by that original f to the power of the exponent minus 1 multiplied by the derivative inside the brackets, which in this case would be 2. So we see the derivative of f would be 6 2x minus 1 squared is x squared plus 4 all to the power of 4. The derivative of g, we again need to use the chain rule there. Exponent comes down to be the coefficient multiplied by g to the power of the exponent minus 1. And then to the derivative, or take the derivative inside the brackets, which would be 2x to the power of 2 minus 1 is 1. And the derivative of the constant will be 0, so we don't write it. So our derivative here will be 8x times x squared plus 4 all to the power of 3. Now, here, let's write it down so we don't forget. We've used the chain rule. And we use the chain rule again to find the derivative of g. This answers this question here. Okay, so we're going to use the product rule now to find the derivative of h. We know that the derivative of h will be equal to f prime times g plus f times g prime. So we can write that all down. Okay, so what I did is I just found f prime here. I replaced it with what we figured out, f prime. Here's f prime multiplied by g plus f multiplied by g prime. Okay, now we're going to take out a common factor. Always at this step, greatest common factor. Okay, so what's greatest here? We see we've got one factor, or one term here, plus a second term here. We're looking for our greatest common factor within each of these terms. I'm going to grab my highlighter. So we see that there will be, well, a factor 2 from here and here, right? The 6 and the 8, the 2 can come out. We've got here, maybe I should change color. Here we've got 2x minus 1s. Here we've got 2x minus 1s. So we've got 2 in common there. And we've also got an x squared plus 4. Here we've got 4 of them. And here we have 3 of them, so 3 would be in common. Okay, so let's grab a pen, and we are going to take out a greatest common factor of equals 2 is going to come out. 2x minus 1, we have 2 here, 3 here. 2 of those can be factored out. 2 are in common. And an x squared plus 4, we have 3 in common. That leaves, in this first term, a 3, because 2 times 3 would be 6. And we've taken all these, and we need one of these, x squared plus 4. Over in the second term, now if we took a 2 out, we were left here with a 4x. We've taken 2 of these out, so we're left with 2x minus 1, and we took 3 of these out, so that would be it. Okay, now let's simplify and gather like terms. I'm just rewriting these greatest common factor we took out. Now I'm going to distribute here 3x squared plus 12 plus distribute 8x squared minus 4x. Okay, and we can gather some like terms there. And when I've grouped the like terms here in this trinomial, here's our answer for the derivative of h of x. I notice here trinomial, I did try to see if it was factorable and it wasn't. So we can leave it as it is. Okay, so for each of these, we are going to, number one, find our f prime, g, and g prime. Then we're going to stick it into the derivative of the function we're looking for. Then we're going to take out a greatest common factor and simplify. Okay, let's go to number 2. During the next 4 questions, I'm going to pause it often just to do writing. I have 15 minutes on this video, and I want to make good use of that time. So if you need to pause to understand something, go ahead. Okay, so this question, obviously, it's a division question. We could use the quotient rule very easily. We could also rewrite this question as a product and use the product rule. I find personally the product rule simpler because mostly I think because there's no denominator. So I'm going to do it this way. We have got our f part and our g part. Okay, I'm going to pause it and leave you to figure out f and f prime, g and g prime here on the right. And that was actually the left. Okay, so we used the elementary rule here of differentiation, and we used the chain rule to find g prime. Okay, so just to refresh your memory, we're finding now y prime. Y prime can also be written as dy with respect to, or dy over dx. Okay, and we know that the product rule is f prime times g plus f times g prime. Okay, I'm going to pause that, and you can fill in the values of that product rule. And then in the second step, all we did is multiply the 2 by this minus 16 to get that negative 32. Now what we want to do is take out the greatest common factor. So from the coefficients, from the 6 and the minus 32, our greatest common factor is a 2. Then when we look in the green, the x's, we've got 2 here, 3 here. The greatest, or the they have in common, is an x squared. And then we look at the factor 4x minus 1. Here we have minus 4, the power of minus 4, and here we have minus 5 of them. You can remember when we did this in Unit 1, we're always taking this much out, or usually anyways. We're going to take common factor of 4x to the power of 5 out, and you'll see why in a second. Okay, so when we take a 2 out here, we're left with a 3. We took all the x's, and we need how many 4x minus 1's? We need one of them. Remember exponents here? We'll add the exponents when we multiply them, so we would negative 5 plus 1 would give us this negative 4. And the second term here, negative 2 times what gives you minus 32? Well, negative 16. And we took all, in the x's, we took 2 out, so we have 1x left. And we took all of the 4x's minus 1's. Okay, now we can simplify and get our final answer. Okay, so we simplified here. We just grouped these x's, and then I noticed that there's a common minus 1 here within that factor. So we took out a minus 1. You can see that this negative 1 is shown in front. Okay, and that is y prime. Moving on to number 3. We'll use the product rule again here, and I've rewritten this radical sign as an exponent. Let's start by identifying our f and our g, and you on the left can find the derivative of f and g. Okay, then we're finding the derivative of f. Again, we can write that if we so choose as dy with respect to dx, and we're using the product rule. These two are being multiplied, so it's f prime times g plus f times g prime. Go ahead and plug those in and see if you can come up with the greatest common factor. Okay, here's the work, and I have highlighted our like terms so we can look at the common factor. Look at the factor here. We've got a fraction. We've also got like factors to powers of exponents. I'm going to flip back briefly to this question. Do you remember this? This is 1.3 maybe, back page 16 in your textbook. Can you see here, similar question, and we were learning how to factor that. We were wanting this x here to the power of 0, so we could get just the constant term. We were also looking at fractions here, what's common when taking out the like denominator. We're going to use this exact same strategy that we perfected back in Unit 1. Okay, let's go back and factor that. Okay, I'm going to let you try to factor it, and I'll do the work here. Okay, so we took out a half, that was the denominator here, and we took out the common 5x minus 1 to the power of negative half, this one here. I want this to be a constant term, so we took that out. Then that leaves us with a 4. A half times 4 will give us this original 2, and you can work through that. We will multiply that out and come up with our derivative. Okay, here we go. I've gathered like terms. I don't mind if you leave it in this form or this form, either way. Okay, moving on to number 4. Again, if you need more time on that, go back and pause it. Okay, here's number 4. I'm going to let you pause it and step through it on your own. It's exactly the same steps as number 1 to 3. We want to do 5 together because that's the quotient rule. So for number 5, you can see, you can write it here as a fraction, and then I would use the quotient rule. You could rewrite it also as a product and use the product rule, whichever one you prefer. I'm going to demonstrate the quotient rule for this question. Would you please, on the left, write the f and g and their primes. Okay, so we found the derivative of f using the power rule, or the elementary rule of differentiation. We found the derivative of g using the chain rule. Now we're going to find the derivative of f of x, and we're going to use the quotient rule in this case. The derivative of f times g, subtract f times the derivative of g, all over g squared. Okay, pause it please and substitute in. Alright, so a couple things. We've plugged everything in here. That looks good. Don't forget the denominator is squared. And then we're going to simplify here. Notice that 2 divided by 2, these 2's here cancel out. Also notice, remember when we have exponent on exponent, we multiply. So this will end up to be 2 over 2, which just equals 1, which is nice in the denominator. Okay, now what we're looking for is the greatest common factor to take out of the numerator. So we've got our coefficients. Doesn't look like there's anything in common there. We've got x's. It looks like there's 3 x's in common. And here we're going to factor out, as per our rule, this factor, 3x minus 1 to the power of negative a half. Okay, try to do that and write the GCF. Alright, so we factored out those 2 we talked about. And now inside the brackets we'll be left with here an 8. And we took all the x's out, all 3, and we took out a negative half. So remember, when we multiply same bases, we add exponents. So to add negative a half, in order to equal positive a half, we have to add 1, or 2 over 2. And then we're left with the 3 coefficient. We took out 3 x's, so we're left with 1x, and we took out all 3x minus 1's. So that should be good. Okay, and that's all over 3x minus 1. Okay, let's distribute the 8 there. And we've got 24 x's minus 8. Remember, this is a 1. It doesn't need to be there. Okay, and then let's gather the like, denominator. Let's gather the like terms. X cubed minus 1 to the power of negative a half times 24 minus 3 is 21x minus 8. And there's no common denominators between 21 minus 8. Now, the only thing I can see here is that this is still the same factor as this. We can reduce that and then it will be good. Okay, remember when we're dividing, we subtract exponents. We're going to omit number 6